Right, we are analyzing graphs of polynomial functions today. So we want to be able to graph them, locate their zeros, and relative max and minimum values. So I'm going to be using a graphing calculator a lot on this. If you have one of those or can get one, that is going to be your absolute easiest way to do this. If you don't have one, we will look at in class how to do it on the Chromebooks. So we have this function here, and we're going to make a table of values and estimate the x-coordinates where the relative maximum and minimum are. So what I'm going to do is I'm going to, on my graphing calculator, go to the y equals button, which is right here, and I'm going to enter this equation in. So I have negative x cubed minus 4x squared plus 5, and I'm going to graph it to get an idea what that looks like. So up here where it says table, if I hit second and graph, it's going to take me to a table of values here. So what this is doing is like when you have to make a table by hand and plug all these numbers in, the calculator is doing that for you on here. So we're going to use that to graph this. So looking at these values, I'm going to start here at negative 4, 5. So that would be right about here. Then I have negative 3, negative 4. So you can see the graph is going to cut through the x-axis there and go all the way down. Negative 3, 4. No, I already did that one, sorry. Negative 2, negative 3. Sorry you couldn't see those. Negative 1, 2. So that's going to be right here. 0, 5. 1, 0. And then the next one is 2, negative 19. So that's obviously off my graph here. So I'm going to connect these in the order that I got them. So it comes here, swoops back up, and then goes down. So this is a basic graph of what we were looking at there. So then it says, then estimate the x-coordinates at which the relative maximum and relative minimums occur. So right here, wherever you see like a hill or a valley in there, this is a relative max, and this is a relative min. So it wants the x-coordinate of those. So I have a minimum that is at about, where was that one? That one was at about negative 3. And I have a relative maximum at, over here, this was 0, 5, so the x-coordinate of that would be at 5. So being able to look at a graph and pick out maximums, minimums, whatnot. Okay, example 2 says determine the consecutive integer values of which x is between, values of x between which each real zero of the function is located. So this is saying, where are the zeros? Where does it cross the x-axis? So I'm going to graph this again first. So I have x to the 4th minus x cubed minus 4x squared plus 1. So this gives me an idea of what I'm looking at. And I'm going to go to my table now so I can get values to actually graph. So I'm going to start here because this is the first one that's going to be even close to being on my graph. So negative 2, 9. It goes a little bit off of this graph. Negative 1, negative 1. 0, 1. So this is going to come down here and then back up there. 1, negative 3. 2, negative 7. And then 3 is up to 19. So that's going to go way up from there. And then it's good to kind of look at your graph again to make sure that kind of matches what you had. So we want to find where these spots are. I'm going to grab a highlighter. Where it's crossing the x-axis, between which x values, that is. So I have here, 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 and here. Those are the 4 spots. I have 4 spots where it's crossing the x-axis, or 4 real zeros. So we want to figure out where those are between. Now from your graph, you can kind of tell where that is. If I look at the table, it's even easier. If I go back to here, whenever this y value is going from a positive to a negative or a negative to a positive, that means that's where it's crossing the x-axis, because up here I have positive values and down here I have negative values. So whenever it crosses or switches sign like that, that's where you're going to have a 0. So right here, in between -2 and -1, which you can confirm that on here, that's where you have a 0. So I have between -2 and -1, because it switches sign right there. It also switches sign right here between -1 and 0. So I'm going to say between x equals -1 and x equals 0. These are just ditto marks, means repeat the thing above it. Then when I go from 0 to 1, that's switching sign again. So there's another 0 there. And then the last one, last time that it switches sign, would be right here, to go from -7 to +19. So that's between 2 and 3. So those are going to be all the spots that we listed on here. Alright, example 3. It says the weight in pounds of a patient during a 7-week illness is modeled by this cubic equation, where n is the number of weeks since the patient became ill. So we're going to graph it first. So again, I'm going to type this into my calculator. Alright, so I get a graph that does not fit into this normal window very well, and that happens a lot when you're doing real-life application problems. So what we're going to do to fix that is we're going to change the window. The window is what we're looking at on here. So it says that we're only looking at a 7-week period, so I really only need to see up to 7 weeks, which is my x, and then I don't need to go back negative in time, but I'm going to make it -1 just so that I can see the whole axis there. The y, my y-intercept on here is 110. So maybe I start at 100 and go to 120 just to kind of see what I can see there. And then I'm going to graph this. So we can see from that I can get a better idea what this graph looks like now. So I'm going to kind of give a sketch of that. So we have weeks. And then this is weight. So the patient started at like 110. And if I look at my table on here, so they went here, 110 was week 0, and then it's going up to at week 7, so they went down in weight and then back up in weight to about 115. So if I say 115 is here, how far down did they go? They went down to like 107. So they kind of dipped down and then came back up. So this is just kind of a sketch of that graph. So we have A done, graphing it. Describe the turning points of the graph and its end behavior. So the turning point would be right here. And let's look at where that turning point was. So we were going from 108, 107, 106, back up to 107. So it's in between week 4 and week 5. We have a turning point because it's going down and then it's going back up. C, what trends in the patient's weight does the graph suggest? So this is saying that they lost weight and then they'll start to gain back that weight. And then part D, is it reasonable to assume the trend will continue indefinitely? So this is saying that if this graph is going up like that, this is suggesting that they're going to continue to gain weight forever. So that part might not necessarily be accurate. So I'm going to say after week 7, it is not reasonable that they would gain weight forever. We hope not, at least. Okay, so we did miss this on part B. Describe the end behavior. So the end behavior is saying as the graph is going to the right, as our x gets bigger, this is going to go up forever, go up to infinity, and that's kind of what we're saying of that's not necessarily reasonable there. Alright, so we need a joke. Here's your last 2, so you can have them there. And your joke, where do hamsters go on vacation? They go to Hamsterdam. Alright, I hope you have a wonderful day, and make sure you're kind to someone today.